All right. Well, congratulations. You made it to the end of the first day and to the best technical session at the RIC. So welcome, everybody. My name is Jeremy Bowen. I'm the Director of the Division of Advanced Reactors and Non-Power Production and Utilization Facilities in Office of Nuclear Reactor Regulation. We're happy to have you here. We got several folks in the room, and those of you joining us remotely, we appreciate that as well. We've got a great panel today. A couple logistics before we get started. You're going to hear this probably more than you care to in the next few days, but first, if everybody could please silence your electronic devices, and a reminder that all sessions will be video recorded. You'll see a QR code for question and answers. The question and answer portion of the session will be handled through that means electronically for both virtual participants and in-person attendees. For those of you in the room, please take a moment and get the QR code up on the screen. You'll see a QR code. Scan that code. That will be using your smartphone device. You can participate in the live polling during that session. And then for those of you that are joining virtually, there's a box in the right-hand corner of the screen with tabs for electronic question and answer, live polling, and feedback. For the live polling, you'll see the slide showing the poll, which indicates instructions for participants to text their responses. In-person participants will text the code next to their choice to the number 22333. Again, that's 22333. If you're participating virtually, once you've logged on to the virtual conference platform and joined the session, there's a tab for live polling questions. Responses from in-person and virtual participants flow into the same queue, so polling results will reflect total responses received from session attendees. And as you can see, we've already got our first polling question up here. Pretty simple. Are you aware of the activities the NRC is doing with regard to microreactors? So if folks want to participate in that while we're going through the session, we'd appreciate it. We'll kind of step through as we move from presenter to presenter. I do want to mention that if you participated in the microreactor session last year, this will probably resonate with some of you. I did have several folks ask me if we were going to have the panel participants wear sunglasses this year. Unlike our friends from the 80s, One Hit Wonder, even though the future is bright for microreactors, we're not going to wear shades. So, all right. With that, if we can go to the first slide, please. Next slide, please. All right. Over the past few years, there's been increasing interest in the licensing and large-scale deployment of microreactors. Their simplicity and scalability have the potential to greatly expand the uses of nuclear power. Whether they operate as part of the electric grid, serve as an independent power source, or provide thermal energy for industrial applications, the NRC is engaged with the microreactor community to enable their safe and secure deployment. Stakeholder interactions have led to the identification of potential policy changes, infrastructure enhancements, and communication tools that would improve the efficient and reliable licensing and oversight of microreactors. In October of 2020, the staff provided the Commission with an early outline of potential regulatory considerations and an initial licensing approach. Further stakeholder interactions indicated widespread alignment that the regulatory issue of highest importance for microreactor developers was the ability to load fuel and perform operational testing in a factory. And in January 2024, the staff provided the Commission with policy options and recommendations to enable that business model. Continued interactions reinforced that the timeline from application to deployment was an area in need of creative thinking, particularly for high-volume licensing. The staff is currently finalizing a paper that identifies policy and process changes that would better support licensing subsequent or nth-of-a-kind microreactors. Jackie Harvey, a Senior Project Manager in the Division of Advanced Reactors, will tell you more about that momentarily. Stakeholder interactions have also indicated the need for further enhancements beyond policy and regulation changes, and additional clarity was needed around how various processes would apply to microreactors. To support stakeholder discussions and track progress on the large number of regulatory topics, the staff recently developed an integrated microreactor activities plan. The plan will also support the staff's response to direction in the ADVANCE Act. Next slide, please. Section 208 of the ADVANCE Act directs the NRC to develop and implement risk-informed and performance-based strategies and guidance to license and regulate microreactors in 8 topical areas, which are annotated on the left-hand side of the screen. Don Pomrose, a senior environmental project manager at the NRC, will discuss an example of the staff's innovative approach for addressing the area of environmental reviews. Overlapping and extending beyond the Advanced Act are the suite of regulatory topics identified by the staff and the microreactor community. The staff's integrated plan provides a mechanism to facilitate systematic approach to ensuring common understanding of the various issues, identifying actions to achieve the desired objectives, and tracking the progress of all activities. The staff will continue to engage with stakeholders in a series of future workshops to address the various topics outlined in the plan. Adjustments will be made as needed, and progress will be communicated on the NRC's public website and through public meetings. So if we can have the results of polling question 1 now, I'd appreciate it. All right, so awareness of the activities that I just described. So it looks like, not quite a 50-50 split, but that's good. We're in the early stages, good feedback for the staff, more communication we need to do, so appreciate that feedback. And if we can put up polling question 2, we'll move on to set up a little bit of Jackie's presentation. So she's going to be talking about high-volume licensing, and we're interested in which one of these priority topics do you see as the top 3 choices you have. So while Jackie's going through her presentation, if you could select your top 3, and we'll touch on this afterwards. All right, and if we can go back to the slides. And next slide, please. So our panel today discusses considerations for nth-of-a-kind licensing to support high-volume deployment of microreactors. In addition to Jackie and Don, we have the pleasure of hearing about the needs of 2 prospective microreactor customers. Tim Williamson from Shepherd Power will discuss the oil and gas industry's interest in microreactors, and Mohammed Badal from the Department of the Army will provide insights on how microreactors can support domestic defense capabilities. Finally, Spencer Klein from the Nuclear Energy Institute will offer an industry perspective on what is needed to ensure success. With that, we'll get started with Jackie. And so Jackie Harvey joined the NRC Region 3 office in 2014 in the NRC's Resident Inspector Development Program. Following qualification, Ms. Harvey supported multiple details as a resident and senior resident inspector at various nuclear power plants until serving as a permanent resident inspector at the Davis-Besse Nuclear Power Station. Following her resident inspector tours, Ms. Harvey held various positions of increasing responsibility in the Division of Operating Reactor Licensing before transitioning to the Advanced Reactor Policy Branch in the Division of Advanced Reactors. Ms. Harvey holds a bachelor's and master's in nuclear engineering and radiological science from the University of Michigan. Jackie?
Great. Thanks, Jeremy. And hi, everyone. As Jeremy said, I'm Jackie Harvey, a senior project manager with the Advanced Reactor Policy Group at the NRC. Before I go into the details of the presentation, I would just want to start off by saying a big thank you to all the NRC staff and managers that have contributed to the efforts I'll talk about today. Staff across the agency continue to work collaboratively to protect public health and safety and enable the safe use of nuclear technology. Next slide. Next slide. Next slide, please. One more. All right, there we go. So first starting off with some background. The microreactors considered in this presentation are commercial power reactors licensed under Section 103 of the Atomic Energy Act of 1954 as amended. Microreactors are anticipated to have unique characteristics such as power levels on the order of up to a few tens of megawatts thermal, small site footprints, expected to have lower potential radiological consequences in large light water reactors, and may rely more heavily on passive systems. And then factory fabricated transportable microreactors are a subset of microreactors that would rely heavily on standardization and mass production, something that we will likely see more of when it comes to rapid deployment and an nth of a kind. Additionally, for this presentation, the term nth of a kind means a microreactor of a standard design that has been previously approved by the NRC through a design certification, a manufacturing license, or a full first-of-a-kind review for a combined license or construction permit and operating license. Next slide. This graphic is depicting a generic deployment model considered by staff in its recent work on of-a-kind microreactor licensing. Its purpose is to provide a comprehensive model on which to base potential approaches for licensing and regulation, but it's not tied to any one specific developer. So starting on the left, the reactor is fabricated and potentially fueled and operated for testing at the factory or manufacturing facility, then transported to the site, operated, and transported from the site for decommissioning. One clarification I'd like to make here is that the reactors considered by staff for the nth-of-a-kind efforts are called what we call transportable microreactors, where the reactor or a substantial portion of the reactor could be fabricated in a factory and then transported to the deployment site where it will be operated at a fixed location. In this context, staff has not explicitly considered deployment of a mobile microreactor, which is where a microreactor is intended to be operated at more than one fixed site on an as-needed, where-needed basis. Next slide. So this slide shows several of the recent and ongoing efforts by staff to provide additional clarity in the licensing process. And I won't go into detail on this, as Jeremy has already discussed these efforts, but I did just want to reiterate that the staff's policy recommendations and other strategies for licensing and regulation of microreactors really focus on increasing the flexibility of the regulatory framework to support the diverse deployment models. So in the next few slides, I'll be going over in more detail the specific staff efforts discussed in the nth-of-a-kind microreactor licensing and deployment white paper issued in the fall of 2024. Next slide. So this slide is depicting the anticipated strategy for nth-of-a-kind licensing of microreactors for widespread rapid deployment and is separated into two phases. The first phase is a robust upfront approval of a standard microreactor or plant design. This includes reviewing as much of the design, operational, environmental information as practicable for the complete plant and its operation. NRC staff anticipates that this information would be described in a design certification or manufacturing license application. The second phase leverages the upfront approval to streamline and accelerate reviews of applications to be focused almost entirely on licensee-specific and site-specific matters. The NRC staff anticipates that much of the operating license review will be verification of site suitability. So for example, through review of the applicant's site characterization and comparison of the actual site characteristics with the bounding design parameters. And then similar verifications will be necessary for site-specific aspects of other programs, such as operational programs. I do want to point out that nth-of-a-kind microreactors could be licensed under either the regulations in Title 10 Code of Federal Regulations Part 52 for a combined license or 10 CFR Part 50 for a construction permit and operating license. And it will be up to microreactor developers and applicants to decide which process best fits their deployment model. And also the regulations being developed under 10 CFR Part 53 will also provide a licensing pathway for microreactors. Next slide. One policy topic discussed in more detail in the nth-of-a-kind white paper is the idea of standardizing operational programs for an operating license application to reference. So in exploring potential efficiencies for the operating license process, the staff is looking at strategies to allow the maximum flexibility to review operational programs in connection with a design certification or a manufacturing license. So really getting at that upfront robust review. Whereas under the current framework, for the most part, operational programs are reviewed at the operating license stage, so a combined license or construction permanent operating license. Due to the unique characteristics of microreactors, staff anticipates that these reactors may not have many site-specific interfaces or attributes or require operational programs of the same scope as we've traditionally seen for large light water reactors. So just quickly on the left, the left shows under the current framework where applicants can currently submit at their option a topical report. The topical report process would help standardize operational programs for an operating license applicant to reference. That being said, staff would still need to review the applicability and appropriateness for the design for each individual topical report referenced in that operating license application. And then on the right side of the slide, that shows the review and standardization of the operational program, where an applicant would have the option to provide information on the programs as part of the design certification or manufacturing license application. And so if the staff reviews and approves the programs, the intent is that the programs would not need to be re-reviewed with the operating license application unless there's new or different information provided. In this case, this would provide for a more efficient operating license application review should the applicant choose to reference those programs. Additionally, with the second option is meant to provide staff and potential applicants the flexibility to have operational programs standardized, but also allow for the flexibility to use the current regulatory tools such as topical reports. Next slide. The Nth of a Kind white paper also included a discussion on strategies associated with several additional topics, as listed on the slide, which I will touch here briefly. The first of which discusses environmental reviews, and Don will be talking about that soon. The next is maximal design standardization, which the white paper provides more detail on the approval of a standardized microreactor design. The NRC staff is also considering approaches for grading the level of site characterization for microreactors of a standard design based on the applicable hazards for the specific design, the amount of margin included in the design for each bounding site parameter, and the amount of margin to the appropriate dose reference values. The NRC staff is exploring approaches for streamlining the review of emergency preparedness, considering that potential accidents for microreactors may result in lower doses at the site boundary. The NRC staff is considering additional approaches for streamlining the review of security, including the possibility to standardize operational aspects of security. Staff is also looking at streamlining more administrative aspects of the microreactor application review, as the thought is the maximal design standardization will likely result in near identical applications. And so we're looking at the use of templates, electronic forms, and automation to streamline that process. And then finally, the white paper discusses approaches that the NRC staff is considering for risk-informed and performance-based inspections at both the fabrication facility and deployment site. Next slide. So next steps. The staff is currently working to finalize and provide to the Commission the SECI on Nth of a Kind microreactor licensing and deployment considerations. Additionally, Jeremy mentioned our ongoing efforts for Section 208 of the ADVANCE Act, and that staff will continue engaging interested parties and stakeholders on microreactor topics. Staff recently held a workshop, as Jeremy mentioned, on the Integrated Microreactor Activities Plan, and we are currently planning for another workshop on mobile reactor licensing considerations in April. Then there's also a commission meeting scheduled in April for the 10th. Lastly, I would like to highlight the new microreactor webpage, which is the QR code on the slide here. We take pride in being open and transparent, and our websites help achieve this goal. Next slide. So finally, I'd like to just share some common themes for maximum efficiency for Nth of a Kind licensing to support high-volume deployment. First off, maximal design standardization is a key aspect and assumption for the most efficient Nth of a Kind licensing, and any deviations from the already approved design will result in additional staff review. Also, proactive stakeholder engagement is vital to understanding industry interests and strategies, and to inform where staff should focus efforts to ensure clarity and reliability with our regulations. And then lastly, staff anticipate that at Nth of a Kind, there may not be a need for as much pre-application engagement in certain scenarios, but I would like to highlight the importance of starting the discussion early, which aids us, the NRC, in addressing these new and novel technologies. So thank you for attending the RIC, and I look forward to the additional discussion.
Thanks, Jackie. If we can get the results of polling question 2 up, please.
All right. So it looks like pretty clear transportation of fuel reactors is
Item of highest interest so far. So, and it sounds like we might have had some polling issues with those who are watching remotely. So apologize if that's the case. Hopefully we can get that resolved. And while we're up, if we can move on to polling question 3, and you can continue to input your changes for that as well. All right, and then the third one will be related to Don's presentation and get us some further insights on the environmental review framework. So with that, Don Pomeros has over 36 years of project management, operations, research, and technical review experience at the NRC's conducting licensing reviews, National Environmental Policy Act assessments and documentation, regulatory analyses, risk assessments, nuclear safety analyses, radiation protection, and the U.S. Navy's nuclear propulsion program. He's a senior reactor engineer in the Environmental Center of Expertise with the Office of Nuclear Material Safety and Safeguards, and is responsible for technical reviews of radiological issues for the NRC's NEPA assessments. Don?
Thank you for that presentation, the introduction. First, I would like to recognize two other Environmental Center of Expertise staff members, Peyton Daub and Mary Richmond, who are also part of the Nth of a Kind Microreactor Licensing and Deployment Working Group, both of which are in the audience today. Next slide, please. And the next slide. As outlined in SECI papers to the Commission and in our letter to Congress regarding Section 506 of the Advanced Act, the Environmental Center of Expertise, or ECOE, is continuing to work to improve our environmental review processes. Specifically for this discussion, the staff believes that alternative pathways can be developed for more efficient environmental reviews of microreactors. While the ECOE is working to do our part, it is also important that microreactor applicants provide us with high-quality and complete applications. The ECOE also recognizes that there are potential users of factory-fabricated microreactors who will want to deploy them at multiple sites within their operating areas over a short period of time. Next slide, please. The ECOE has been working since its formation in 2019 to enhance the quality, timeliness, and efficiency of environmental reviews. The ECOE published in 2020 Interim Staff Guidance 029, providing guidance on tailoring environmental reviews for microreactors. The ECOE also published in 2024 a draft new reactor generic environmental impact statement, or GEIS. Once the rulemaking is finalized, the time and cost for environmental review of new reactor licensing applications should be substantially streamlined. The ECOE has also established working groups who have developed a proposal to the Commission on NEPA implementation under the Fiscal Responsibility Act and a report to Congress on environmental efficiencies as required under Section 506 of the Advanced Act. Additionally, the ECOE has consistently met schedule and page length targets for new reactor environmental reviews established under the Fiscal Responsibility Act. Next slide, please. One such example of the ECOE's continuing efforts to increase efficiency is our recent and ongoing work with respect to microreactors. The ECOE studied unique characteristics of microreactors, such as their smaller footprint and anticipated fewer environmental impacts. The team came up with 4 potential alternatives. We are recommending a systematic, phased approach that ultimately could employ elements of each of the alternatives in a series that progresses incrementally. This systematic, phased approach would allow applicants the flexibility to utilize the alternatives that best suit their needs. That is, as industry develops or advances the design, the procedures could subsequently initiate elements of other alternatives to provide additional streamlining. I've also listed a few other considerations that may affect environmental reviews for microreactors. Next slide, please. A key aspect of the staff's approach for microreactor licensing is the development of an online portal. Alternative 1, displayed in green, generally represents the current review process but incorporates a newly developed budget model scaled for microreactors. This approach leverages the new reactor GEIS and other recent process improvements and efficiency efforts. Alternative 2, displayed in gray, involves development of a design-specific GEIS for each standard microreactor design at the first-of-a-kind stage. At the nth-of-a-kind stage, if there is a design-specific GEIS for an applicant's selected design and there are no special considerations at the selected site, the applicant could tier from the developed design-specific GEIS and analyze only the environmental topics and resource impacts beyond those analyzed in the design-specific GEIS. Alternative 3, displayed in blue, involves relying on a set of bounding plant parameter and site parameter envelope values, or PPE and SPE values, that could be adopted from the new reactor GEIS and other sources to better reflect microreactor designs, enabling broader applicability across siting scenarios. This is similar to general permitting approaches used by other agencies. Alternative 4, displayed in orange, regarding future category exclusions, requires sufficient review experience to demonstrate that nth-of-a-kind projects have no significant environmental impacts. This would involve defining criteria based on review experience, PPE and SPE values, and NRC guidance. Implementation would require rulemaking to modify 10 CFR 51.22. Next slide, please. The staff has begun to develop the phased approach. This phased and flexible approach will allow for an applicant to select a submission process that aligns with their objectives. The microreactor online portal development, illustrated in blue, is currently underway in coordination with the NRC safety staff. It is anticipated that the online portal will support each type of submittal. As the alternative progresses in development, the online portal can be updated to accommodate new designs and efficiencies. Other activities associated with the pre-first-of-a-kind phase under Alternative 3 include development of the bounding PPE and SPE values and associated environmental screening worksheet templates. Alternative 2 design-specific GEIS activities would commence once a design-specific first-of-a-kind application has been received. The microreactor online portal would be then updated for each successive first-of-a-kind design, allowing nth-of-a-kind applicants to tier from a design-specific GEIS for that design. During the nth-of-a-kind stages, the applicant would be afforded the flexibility to utilize any of the submission processes related to alternatives 1, 2, or 3 on the online portal. The post-nth-of-a-kind, namely the category exclusion process of Alternative 4, would become available after appropriate historical documentation and rulemaking. A process for applying under a category exclusion would be included in the microreactor online portal at this juncture. Next slide, please. This figure shows a potential pathway that the various phases of licensing and deployment of microreactors could occur, from the factory fabrication phase through to the deployment phase. To come to full fruition, a number of actions, both by the NRC and by microreactor developers and applicants, will need to occur. For example, the online portal with an environmental screening worksheet would be ideally in place by the time the actual manufacturing of the microreactors begin. If this is successful, potential microreactor applicants could have a site licensed and constructed in time for the first microreactor completing the manufacturing, testing, and inspection process. Follow-on site-specific licensing and construction could then rapidly follow. Next slide, please. The concept of utilizing a licensing or permitting portal is not new. The staff investigated other agencies' use of online portals and environmental lists for environmental reviews for the processing of the agency's permits. For example, there is an environmental checklist used by the Federal Communications Commission. Given that the NRC environmental reviews are unique, the online portal development will be tailored to NRC processes. The staff would also assess whether artificial intelligence can be integrated into the process for further efficiencies. Initial indication from industry looks to also recognize the efficiency in utilizing online portals. Next slide, please. Given the numerous press releases and notices, the staff anticipates a wave of applications for microreactors critical to providing the energy needed for economic growth over the next several years and decades. The staff is aware that the success of these anticipated microreactor projects depends on the ability to expedite reviews, including environmental reviews for smaller power generation facilities that should have smaller environmental impacts than traditional large light water nuclear power plants. Next slide, please. The staff is optimistic that the phased approach in implementing the alternatives presented can substantially reduce the time needed to review nth-of-a-kind new microreactor licensing applications. However, there are still factors that may be out of NRC's control, such as the fuel and supply chain to support the manufacturing of microreactors. Applicants, however, can maximize the ability of the staff to complete expeditious reviews by submitting accurate, technically complete applications. Applicants can also engage staff in voluntary pre-application discussions prior to any submittal of an application. Applicants should also recognize that the staff is required to consult with other agencies, such as Fish and Wildlife Service and state and tribal historic preservation officers. Applicants are encouraged to take advantage of emerging opportunities to engage directly with consulting agencies when possible. Next slide, please. The staff in the ECOE has worked over the last several years to streamline the agency's environmental review process without compromising its purpose and effectiveness. These efforts are already resulting in substantial efficiencies that have shortened the time needed and reduced the cost of environmental reviews. In line with the Advanced Act, the alternative approaches currently proposed by the ECOE for the nth-of-a-kind microreactors would, if successful, result in efficient environmental reviews consistent with microreactors' anticipated small environmental impacts. The ECOE seeks innovative efficiencies while still continuing an effective, predictable, and transparent process that will continue to effectively inform the Commission of environmental impacts and continue to give stakeholders, tribes, and other engaged members of the public a voice in the decision-making process. Developing efficiencies tailored to microreactors with their anticipated minimal or reduced environmental footprints is a key part of this effort. Thank you, and back to you, Jeremy.
All right. Thanks, Don. If we can get the results of polling question 3 put up, please.
All right. So, clear indication, Don, we got some work to do, so.
All right, very important. Don, appreciate that. With that, we're going to move on now to Tim Williamson from Shepherd Power. A native Texan, Tim graduated from Rice University in 2001 and began his career in the United States Navy as a submarine warfare officer. He spent 12 years on active duty, serving in a variety of leadership roles, both at sea and ashore. He earned his MBA from the Naval Postgraduate School in 2008. Tim hired on with NOV in 2013 as a project manager with a subsea blowout preventer product line and served in a variety of project, program, and quality management roles. He also served as a manufacturing operations director in the intervention and stimulation business unit and in several data and analytics roles with the NOV corporate group. He presently serves as the Director for Regulatory and Public Affairs for NOV Shepherd Power. In this role, he leads Shepherd Power's regulatory engagement and modernization efforts with the NRC, state and local leaders, and other public stakeholders. Tim?
Thanks, Jeremy. Afternoon, y'all. There we go. That's good. I know it's late. Well, first of all, thank you for the warm welcome. We appreciate the invitation to come and share today. And I noticed we have yellow roses, so you made this Texas specific. I really appreciate that, too. So this afternoon, I'd like to share a little bit about our company, what we're doing, our interest in microreactors, and then finish off with some high-level perspective on where we see regulatory issues and opportunities working with the NRC to help address those to commercialize deployments of microreactors. Next slide, please. So who are we? NOV is a company, we're an oilfield services and equipment company, which basically means that we build the stuff that goes out to drill oil wells, recover oil and gas out of the ground, get it into pipelines, and all of the associated equipment with that. So whether it's topside equipment like drilling rigs, or whether it's things that go downhole like pipe and bits, all the associated control systems, things like that, that's our business. We work both onshore and offshore. During the mid-2000s to mid-2010s, we delivered somewhere north of 25 to 30 offshore drilling packages to shipyards in Southeast Asia, supporting a build-out of Generation 6 drill ships. So a lot of experience in heavy manufacturing, a long history. Our company goes back all the way 150 years, the beginnings of our company does. So very good, a lot of experience in heavy manufacturing, in operations that deal with high-risk environments and high-consequence systems. So engineering, design, quality, manufacturing, all of those things. Who is Shepherd Power? So we are a relatively new, wholly owned subsidiary of NOV, and we are interested in helping to service our customers, principally in the oil and gas business, who are looking for reliable power that they can deploy out to places like the Permian Basin of West Texas and eastern New Mexico, or places as far as maybe the North Slope of Alaska. So you're talking about areas where grid build-out may not be substantial or may never get there, and that there is a demand and a need for high reliability power and process heat. Next slide, please. So our mission, as it says on the slide here, is we want to commercialize advanced nuclear reactors by filling the role of, I guess what we would call a developer, an owner and operator, develop, own, and operate to offer long-term energy contracts to customers who want to offtake that energy. And the reason that we're doing this is because we believe that energy availability, particularly for industrial applications and in remote areas, it needs to be taken for granted. We saw recently the president sign an executive order talking about energy dominance. Being energy people in the energy business, we understand that, and that energy, reliable energy, low-cost reliable energy, is critical to human flourishing. And so a lot of folks in our industry take a lot of pride in that, in doing that every day for a living, and we think that this technology can help do that as well. Next slide. So what's our end goal? We want to deploy reliable baseload, economic, emissions-free energy to remote locations to ensure freedom to operate. So what does freedom to operate mean? Freedom to operate does not necessarily mean the cheapest electron you're going to buy. In fact, I can guarantee you that it doesn't. But what freedom to operate does mean is that this technology can help support economic growth, particularly in areas that are remote and have a hard time getting critical infrastructure. So we think that in order to do that, there's some areas we have to tackle. First of all, supply chain. That is going to be a significant issue, both on the fuel side and on the reactor and balance of plant side. Second, we believe that manufacturing expertise needs to be brought to this microreactor technology. So I mentioned our former business, or it still is our business, but now that the boom's over, it feels like a former business. Manufacturing heavy equipment for offshore use. When we started delivering drill ship packages to Southeast Asia for incorporation into ships in these shipyards, the first ships that were coming out of the yard in the early to mid 2000s were somewhere in the neighborhood of $1.2 to $1.5 billion per drill ship. By the time we got to the mid 2010s, right before the bust due to shale gas, we were delivering the same rigs out of those shipyards for about $500 million. So you can see we had almost, and in some cases, up to 60 to 65% cost reduction in these major capital projects. Now, it wasn't just NOV, but we were one of a number of suppliers working with the shipyard that learned by doing. We had to figure out how to deliver these things cost effectively. We had to learn how to scale production up. I think in our first year, we shipped maybe 1 or 2 of these drill packages. By the time we got to the peak of our deliveries, we were shipping 15 to 20 a year. And so you can see that there is we have a demonstrated history of showing how you can take major industrial manufacturing and scale that up. And we think that that can be brought here to the microreactor world as well. Licensing and regulation. We'll talk a little bit about that in a second in more depth, but there are real commercial constraints around deploying microreactors. We need to be able to license these units at the speed of relevance, which means that the licensing timeframes need to fit within the capital expenditure decision timelines that our customers have. They don't have 5, 10, 15 years to decide to develop a project. Sometimes that timeline is 24, 18, 12 months, things like that. And so we need predictability in the regulations to be able to license these units as they come out of the factory. And then finally, operations. There's going to be a very, we believe, unique operations model unique to the nuclear business. We're not talking about traditional large commercial utility scale plants. We're talking about something that looks a lot more like an oil field services business. And so we think that our experience working with our customers and understanding the cost drivers, the sensitivities, the need to deliver, the timeframes, that we can develop operational models that use advanced reactor technology, microreactors, to deploy these and to service them in a commercially viable way. Next slide. Okay, so we talked a little bit about those 4 areas. We'll go ahead and go to one more slide. I want to focus on regulatory, since that's why we're all here. So in early 2024, we came and visited the NRC here in Rockville and brought some customers with us and had some very nice meetings with the commission and the senior staff. And the message to the commission was, we have customers who are interested in this technology. And they're potentially interested in deploying a lot of this technology. But being good project management folks, when they look at their stoplight chart of the risks, there's one big flashing red light on that chart, and it's regulatory. The technology may be great, it may be interesting, it may be a good fit use case, it might be economically viable, but if these units can't be licensed in a timely fashion at the speed of relevance, then we're not interested. And to our, to the NRC's credit, to the staff's credit, they have taken up that challenge and said, we'd like to work on this project with you. So working with NEI, and Spencer's going to talk about this in a bit too, we helped to coalesce around a list of issues that we believed represented what we knew about what the risks were to get to 180-day licensing and 1% cost for deployment. Working with NEI to put that into a letter, the staff has used that input from us and from others in the industry to help to begin to formulate the ideas that you're hearing today. And I'm super excited to hear, what we've heard from Jackie and Don. That's, I believe, just the beginning of this conversation. But I would like to say personally that the agency has been very responsive, and we are very encouraged by the progress that we're seeing being made, and so are our customers. Next slide. I'd like to leave with 4 areas. Just think of these as buckets for regulatory opportunities that we have, and we can obviously take some questions on this later, I think. But the 4 areas that we believe are sort of at the front of the mind for us on regulatory right now are siting, supply chain, licensing and oversight, and operations. So first of all, we believe that the entering assumption here, you'll see in yellow behind me, right, is that we can innovate because we're dealing with technologies that have a high degree of inherent and passive safety, right? We're not dealing with technologies, we believe at this point, that take the same level of operator intervention to ensure that the public health and safety is protected. And so we think that that gives us some opportunities to look at ways to do things differently. Siting. Alternatives to multi-year, multi-million-dollar pre-projects. Right now, in order to site a reactor in the United States, it is like a project in and of itself. We think there's some opportunities there to use things like readily available data and to take generic approaches, and some of the stuff that, some of the items that Don listed can help with that. We think in the supply chain, we need to be casting a much wider net. We think there's opportunity in the commercial codes and standards that are maybe not presently used in the nuclear industry, but are already used in high consequence industries that are also regulated, and the ability to more rapidly evaluate and adopt those to help with things like material selection and design and ultimately manufacturability. I'll include with that expansion of thinking outside the box on quality management systems. There are a lot of companies that deliver high consequence product that build to specs like ISO 9001 or American Petroleum Institute Q1. We think many of those requirements have a lot of overlap with the requirements in NQA1 and could be adapted quickly as a quality management system to help expand the supply base. Licensing and oversight, aiming for continuous flow. I won't belabor this point, but when you see the term continuous flow, you should think Toyota production system, right? Folks who are the best in the world at figuring out how to get something through a process as efficiently as possible. I think there's a lot of opportunity for the staff in particular to learn from the manufacturers. And so I'll leave it there, but there's a good follow-on conversation to have about that as well. And finally, operations and maintenance. When you have high capital expenditure for these units, the trade-off has to be improved O&M. It has to be a very, very tight O&M budget. And so looking at optimized staffing, looking at the ability to remotely operate and monitor these facilities, we believe are not only technically feasible, but are going to be an absolute requirement for commercial viability. So with that, I will turn it back over to you, Jeremy, and happy to answer any questions later.
All right, thanks, Tim. And again, appreciate the partnership that Shepherd Power's been having with the staff. It's been good interactions, helped us think creatively, so thanks. It sounds like we're having some issues with the live polling online and Q&A online, so if it'd be possible if we could get the QR code for the question and answer put up on the screen while I introduce our next speaker, I'd appreciate it. All right. Next, we'll hear from Mohammed Badal, who joined the Army, the Office of the Assistant Secretary for the Army for Installation, Energy, and Environment in April 2024. And he is currently the Program Director for the Advanced Nuclear Power for Installations Program for the Army, leading a group of cross-functional team with members from the Department of Defense, Department of the Energy, and the National Labs. Mo began his career as an enlisted soldier at Fort Carson, Colorado in 1997. He was later honorably discharged as a staff sergeant and began his chief warrant officer career in December 2005. In his last assignment as a senior warrant officer, he served as chief of the Contingency, Construction, and Operational Energy Branch within the Army's Headquarters Office of the Chief of Engineers. He also established the Nuclear Power Branch in the Office of the Chief Engineers in 2020 and served as an operational energy advisor. After retiring from active duty in November 2023, he joined the Idaho National Lab as the program manager for the defense of microreactors. Mo?
Thank you, Jeremy. So first of all, good afternoon, ladies and gentlemen. It is a great deal of pleasure that I got an invitation from Jeremy to join this party. Quite a surprise when I came this afternoon, and it is a party. So with that, I want to say, before I get started, I want to give a shout out to all the regulators, all the nuclear engineer professionals, all the funders for your lifetime dedication and service to bring nuclear energy to bear. We need actually all of yours effort to bring nuclear energy to bear for our installations, for the United States, and for the world. I'm here today really, more than ever before, there is an increased demand for energy for DoD and the military installations. The need is very clear. We need islanded capability. We need on-site generation. We need resilient power for the increased demand. If you think about our installations, they are really a strategic locations where we live, we train. It's the foundation for our readiness, and this is where we prepare for our next big fight. So having a resilient energy is something that we need, and then I think nuclear energy can help us. As a retired military officer, I got to live in many of these installations, and then CONUS, and then overseas enduring sites that have significance in terms of where we fight from our adversaries. So the resiliency just don't extend here in our CONUS in our country, but in overseas locations, make sure we can deliver and fight our next fight to win. Next slide, please. So, July of 2023, we began to think about how to bring resiliency to our installations, and we looked at our portfolio of energy sources, the combustion engine to natural gas to, solar, all the renewable sources, geothermal. But one energy source that we did not really consider before 2016. That's just the reality of the environment, the leadership, the policy. There's many factors goes into that. But with the right leadership in place, we had the green light from our leadership to say, let's explore nuclear energy for our installations. So after some, we call it, MDMP in the Army, military decision-making process, we quickly made some determination to go with commercially owned and operated microreactors, so we can site them locally on site, and it's behind the meter, so we can control and manage, for our critical facilities. So what the scope of the project is really, it's cradle to grave. We know it's still in advanced reactors. We are still in a first-of-a-kind window. We have not delivered a single plant yet. So we understand there's some challenges. So we are seeking through, with partnership with Defense Innovation Unit, a life cycle starting from design, construction, operation, decommission, cradle to grave, basically a project that will be regulated by a Nuclear Regulatory Commission. So I think that is basically where we are in the state of the technology, and then we have to think through that process. So mission objectives is clear, that we want to enhance by our mission readiness. We want to make sure we have safe, secure, and reliable energy sources. And of course, the third bullet down there, it's really important to us as we talk through our microreactor, advanced reactor technology exploration. We talked about how to really help simultaneously stimulating the industry to bring bear this technology for the United States. So that's also really important to the DoD itself. Next slide, please. We can't do this alone. So I think initially we kind of looked at who are the key stakeholders can help us bring this to bear. So we quickly thought about it have to be a whole of a government approach. Within the Department of Defense, I represent the United States Army, so it's a service level initiative, but then we quickly identify key stakeholders at the Office of Secretary of Defense under those auspices. And then a key strategic partner was a Nuclear Regulatory Commission is obvious, it came to us. And then Army, we have not done nuclear energy since 1976, even though we started the project in 1954, and then we ran nuclear power plants for the DoD, and actually we were leading nuclear energy for the United States. We shut down our last project in 1976, last nuclear power producing plant. So we don't have the subject matter expertise within in-house. So we quickly identified that our national labs does have those technical background and the working knowledge because they are testing those advanced reactor technologies with our tech drivers. So we quickly identified the strength of the multiple national labs. So currently we have memorandum and understanding, interagency agreements with 6 different national labs, and we have a bench of nuclear engineers. Last time we interacted, it was 21 in the room with multiple disciplines as we go through the process. So again, whole of a government approach. We are working with national labs to bring the subject matter expertise we need as we go through tech evaluation. And of course, Installation Management Command for the Army and the Army Material Command, that's where our installations are. So we couldn't do it without their command support. So the last thing I want to mention in this slide is the utility providers. Again, they are our partners at our installation. So as we go through looking at the technology, how we bring to bear, we see multiple approaches like Tim was talking about. The operating model, the ownership model, that all combination, how do we bring that bear? So we have to work with our utility providers as we go forward. Next slide, please. So these are our 2 approaches that we determined. The microreactors we determined as 10 or below at the time when we made our decision. At the behind the meter, and then the utility scale, grid facing, it's a whole installation and resiliency. As we looked at them, it's between 200 to 300 megawatt electric. So again, as I go through Jackie's presentation, Don's presentation, it's kind of clear that as we explore different sizes of technology for our installations, those considerations for how we deliver this, it have to be a menu of services and options that as we have to look into bringing this technology. So I think for both, I want to highlight one thing here in both approaches. There will be a power purchase agreement at the end for the investor or the tech investor or the owner to recoup the investment from our installations. Currently, the DoD have a 30-year power purchase agreement options. For this scope, the focused application, we solicited for a 20-year power purchase agreement given the size of the microreactor. On the right, you can see what we did is we partnered with the Defense Innovation Units, with the other Transaction Authority. We learned and we saw that there was some rigidity within the FAR-based approach of utility, exercising utility partnerships. So we chose Defense Innovation Unit and other Transaction Authority to get the flexibility we need to bring a nuclear-like technology to bear. And that gives us an option to work with multiple vendors with multiple sizes, like in a family of microreactors or advanced reactors. If all goes well and we have our leadership's approval, we might be able to work 5 to 7 vendors first-year design options. So we'll see what happens with, as we go exploring this and finding out the viable technology and receiving our leadership's approval. Next slide, please. Again, this is just showing the process step. Again, we're taking this very seriously. And within the process steps, it's showing as we go through evaluating technical review, technical readiness level and the manufacturing readiness level, the organizational readiness level, we are taking a deep dive into all this. I have listed as 16 nuclear engineering discipline areas. We're taking a deep dive into every technology that's out there right now. Make sure we identify the most design-ready technology that has the regulatory path with Nuclear Regulatory Commission, because without the licensing, for us, we will not be able to do any business with them. So it's very important that we have a regulatory path forward with all the criteria applied in this slide. Next slide, please. This slide is really, I want to make it very clear. DoD, we operated owned, operated nuclear plant between 54 and 77. We have the permitting ability to license and operate our own reactors, specifically when it is behind the meters. So with a defense purpose only, exercising 91B. But then we chose NRC Licensing Authority, particularly because we knew NRC has the public confidence and the safety record for delivering nuclear licensing and operating in the United States, okay? The Army, didn't want to get into a nuclear energy business or licensing reactors when we haven't done this in 5 decades, right? So we could do it, but we want to work with NRC and make sure we continue to exercise NRC's licensing on our installations. They also have the subject matter expertise that we need, and the current, the framework of legislative language with the Advance Act. We see that our project extends the partnership with NRC's piloting opportunity to deliver maybe licensing within 18 months or so as we go through vendor selection process in the future. Again, these are I would say thought out decisions that we made as we pilot our program with NRC, as we look through the timeline and the resourcing requirements, and then the design readiness for pre-application. We understand that that's really critical as we go through this. But again, we had meeting with the chairs, our leadership. We see eye to eye on this as we work together going forward. Next slide, please. And this is just a notional slide with our 2030 timeline. We want to have a operating nuclear power plant on our installation by 2030. Initially, we opened up our solicitation with Defense Innovation Unit for 2 microreactors on 2 installations. That's the Army's. Since then, Air Force have joined our project. So we have 2 services now exploring nuclear energy through our acquisition process with Defense Innovation Unit. So we're hoping that we will be able to deliver microreactor nuclear power plants more than 2 installations. With that, thank you, Jeremy.
All right, thanks, Mo. Exciting. The staff's really excited to be able to support the Army and the rest of the Department of Defense in this effort. So, and then our last presenter today will be Spencer Klein. Spencer joined the Nuclear Energy Institute in 2024 as a senior project manager in New Nuclear in the Technical and Regulatory Services Division. He leads programs designed to improve the commercial environment for the nuclear energy industry's prospects for deploying new nuclear power plants, with a focus on licensing processes and lessons learned, international regulatory harmonization, regulation of rapid high-volume deployment of reactors, and the deployment of microreactors for military and space-based applications. Prior to joining the NEI, Spencer worked for the Ultra Safe Nuclear and the Tennessee Valley Authority. Spencer is a certified project management professional and holds a bachelor's and master's degree in engineering management from the University of Tennessee at Chattanooga and a certification of specialization in leadership and management from Harvard Business School. Spencer?
Thanks, Jeremy. Since I am the only thing standing in the way between us and happy hour, I will go ahead and jump right in once my slides are up. Okay, perfect. Go ahead and jump to the next slide, please. Thank you. So in July of this past year, we submitted our proposal paper titled Regulations of Rapid High-Volume Deployable Reactors in Remote Applications and Other Advanced Reactors, which we gave the acronym RIDRA. And it provides proposed alternative approaches for 31 topic areas to current regulations that would enable new business models, specifically focusing on applications with technological characteristics and concepts of deployment and operation for high-volume nuclear reactor deployment, and would maximize the applicability of the proposed approaches to other advanced reactors and business models that were not specifically defined in terms of the interface within the current regulatory framework as it is today. The RIDRA business model adopted the business requirements identified by our friends at Shepherd Power in their letter to the NRC, which described the use of reliable and affordable nuclear heat and power for oil and gas operations, and stated that the two business case requirements relevant to the NRC regulatory framework that are necessary to enable the business model are that it takes no more than 180 days from the date a precise location is identified for a microreactor to the time it is deployed and operating, and that the overall licensing and ongoing oversight costs need to be less than 1% of the total cost of manufacture and operations. Next slide, please. That said, the central goal of the RIDRA concept is to enable alternative approaches developed for a high-volume deployment business model that could be applied to as broadly as possible all new reactor technologies and business models. This is built upon technology-inclusive, performance-based, risk-informed, and graded approaches. This goal for broad, general applicability is balanced against the need to develop approaches that specifically enable RIDRA and other advanced reactors in other applications by addressing the unique considerations of those technologies and their concepts of deployment and operations. 20 of the 31 proposed approaches are expected to be applicable to any advanced reactor. The approaches are graded such that advanced reactors that meet more stringent conditions are able to realize greater benefits. The outcome of these graded approaches is a consistent level of protection of the public health and safety and the environment across a wide range of technologies and concepts of deployment and operations. In this way, the unique aspects of RIDRA and other similar advanced reactors can be most appropriately addressed while also ensuring maximum applicability to all advanced reactors. Next slide, please. The concept of rapid, efficient, repeatable licensing, which we refer to as RELIC in the RIDRA proposal, enables the RIDRA concept based on a business model that depends on a schedule of 6 months from site identification to operations, as I previously mentioned. Within that 6 months, the regulatory process would need to be no more than 5 months, of which the final approval and authorization by the NRC would need to be completed in 4 months or less. The central concept around rapid, efficient licensing is to minimize the scope, content, and purpose of the site-specific reviews. This is not suggesting that the NRC cut corners, but since it is recognized that these reviews must also be effective at providing reasonable assurance of adequate protection of the public health and safety. The concept is in the when, who, and how the reviews are performed and assembled together as part of demonstrating that the use of an advanced reactor at a particular site provides reasonable assurance of adequate protection of the public health and safety. Next slide, please. One more slide. There you go. Sorry. The common theme to each of the fundamental elements to a rapid, efficient licensing process is to move the scope and content of information that has traditionally been in the site license application into licensing processes that can occur one time prior to the site-specific license application. In doing so, these one-time upfront approvals will establish the minimum set of bounding site parameters that are necessary and sufficient to verify that the site complies to these prior NRC approvals. This enables the NRC's review of the site-specific licensing application to be a verification of compliance with the site parameter envelope, ensuring that the site license conforms with all of the NRC conclusions from the prior safety and environmental reviews, along with the commensurate public engagement processes. It should be noted that other advanced reactors that do not share all of the characteristics of those reactors previously discussed could still see more rapid licensing and deployment timelines than the current NRC process enables through the use of substantial portions of this process. Next slide, please. To support high-volume licensing, we are currently working to develop guidance, methodologies, and bases to reduce the data collection burden that currently plagues applicants at this time. One such area is for aircraft impact assessments. NEI believes that the NRC can define a class of reactors such that it is highly unlikely that an aircraft could impact the reactor or damage the fuel in a way that results in a significant radiological release. The NRC could develop performance-based criteria related to the footprint, radiological inventory, thermal power level, or some combination thereof that would serve as the basis for exempting plant designs from compliance with the aircraft impact assessment rule in the near term and eventually serve as a basis for a rulemaking. and this is also an approach that is consistent with the proposed Part 53 rulemaking, that is currently ongoing. Next slide, please. Another area that we are actively working on is on meteorological data collection, where we are working to develop an alternative methodology that allows the use of reliable, pre-existing, and readily available data, such as that from the NOAA database, state or federal environmental protection agencies, or other local sources, to meet the applicable operating dose and emergency planning requirements. In cases where these data sets either do not exist or are not sufficient to meet the requirements, they could be supplemented by locally measured data from commercially available meteorological equipment. The proposed approach to use pre-existing data would enable the establishment of meteorological and weather conditions in days or weeks, rather than 2 to 3 years as is currently required today by regulation. It would also enable reduced costs that are small fractions of the several millions of dollars required to procure, install, and operate an on-site MET tower. Next slide, please. In the realm of seismic analysis, we are working to develop alternative methodology for site geocharacterization that is commensurate with the potential consequences of advanced reactors and enables rapid and confirmatory comparison to a site parameter envelope used for site-independent design. Within that methodology, the site seismic characterization will allow for the use of reliable, pre-existing seismic hazard data cataloged for locations across the United States. The United States Geological Survey's National Seismic Hazard Model provides readily available national seismic hazard data that can be used to characterize site-specific seismic vibratory hazards without performing a unique evaluation. Next slide, please. NEI is also working on the bases for which current regulations for population siting could be revised to account for the NRC's 2023 final rule establishing alternative emergency planning zone sizing requirements for advanced reactors and other new technologies, which provides the necessary technical and regulatory bases for enabling the siting of new reactors in or near large population centers without increasing risk to the public or reducing defense in depth. We are recommending that the NRC consider revising the relevant language and regulations to allow the low population zone and population center distances to coincide with the site boundary for those sites at which an applicant can demonstrate that no plume exposure pathway, EPZ, is required, or that the EPZ does not extend beyond the site boundary. This change would simplify licensing of advanced reactors in urban areas where the population density may be large, but the reactor's small size or the design already substantially reduces risk to the public, as demonstrated by the facility's site boundary, EPZ. Modernized population-related siting criteria that are risk-informed, performance-based, and consequence-oriented will provide efficiencies for not only the NRC, but also applicants as advanced reactors are proposed for non-electric end uses, reindustrialization at brownfield sites, and energy and economic transitions for communities with retiring facilities. Last slide, please. The process for implementing the regulatory approaches that I've mentioned today is to pursue changes to these regulations by incorporating them into existing rulemakings or through a new rulemaking. Notably, there are a few topics for which congressional action, such as an amendment to the Atomic Energy Act, is needed to achieve the proposed approaches, or which would enable other options for addressing the topics that are identified. The NRC is doing a considerable amount of work that encompasses a broad range of reactor technologies and applications, much of which would benefit high-volume deployable reactors and includes the Part 53 rulemaking and the Advanced Nuclear Reactor Guides, as we discussed today. The NRC has also done a considerable amount of work specifically applicable with microreactors and manufacturing license that has also established a foundation for many of the topics addressed by our RIDRA paper. And we look forward to continuing to engage with the staff and industry on the response to the congressional directions set out in the ADVANCE Act, as well as future topic-specific workshops to explore the implementation of other proposed approaches that could be applicable to all advanced reactors. Thank you.
All right. Thank you, Spencer. All right.
Good job getting everybody closer to.
To happy hour. So we actually have probably more questions than we're going to have time to get through, so we'll just jump straight into it. And Jackie, I'm going to start with you, and I'm actually going to give you two because I think one's pretty simple. First, can you give a little bit more information on the next workshop that we've got scheduled in April? Registration details, how participants can find out more information. And then after that, if you can go into describe the NRC's actions and timings being taken to achieve remote operations and when we see that might be possible.
Okay, great. Well, thank you for the question. I appreciate the question with the clarifying detail on the next workshop. So the next workshop, I believe, is scheduled for April 21st. And it's going to be essentially the entire afternoon, 1 to 5 or thereabouts. And anyone can, it should be live right now, the notice on the public website. So if you just go search for April 21st, you should be able to find the information and just add it to your schedule, your calendar, and call in day of. All right, and then.
Thanks. Oh, sorry, Jackie.
No, go, sorry. The second question was related to remote
Yes,
operations.
when we think we'll be able to discuss remote operations and when that might be possible.
Okay, well, what I'll say right now is that the staff is working on it. We understand there's significant interest in the use of remote operations for various deployment models. With that said, highly encourage industry and other interested parties and stakeholders to continue engaging with the NRC, either through workshops and providing additional information for us to aid in our understanding of what those deployment models will look like, and that'll help inform our milestones and schedule.
Great, thanks. All right, Don, we'll go to you next. Are there aspects of the environmental reviews and the nth-of-a-kind approach that are outside of the staff's control? How do you plan to address these?
Well, one thing that we understand that there's a potential for a wide range of microreactor designs from a single microreactor at a site to multiple microreactors at a large site. And so in standing up this portal in the environmental summary worksheet, we need to have a good set of PPE and SPE values in order to populate that. And that's, really something that's going to have to come from the developers. So the importance of pre-application meetings, looking at how we could set up these values either as a generic one for a good range of microreactors, or they need to be specific ones. It's one thing I think we need to have a discussion on. In the past, just from my professional experience, I know that EPRI has done studies for various aspects of licensing issues, and so potentially maybe that's something there. We've also had internal discussions about whether or not an ANS standard related to PPE and SPE values would something be beneficial for microreactors, because we know that the various microreactor developers, they want to keep the information proprietary, their business plan's proprietary, but we still need to have that ability to create a good set of PPE and SPE values that would go into the portal. And then, as I mentioned before in our presentation, a lot of the cases, the selection of the site can have a very big impact. So getting any idea of what's going on at the site ahead of time is also beneficial, because we've seen, various consultation processes have taken a little bit longer than maybe we anticipated. But they may have special situations that we need to be aware of, hopefully earlier rather than later. Thank you.
Thanks, Don. Tim, we'll go to you next. How soon does the oil and gas industry deployment model need implementation of an nth-of-a-kind approach?
It depends on who you ask. It goes all the way from yesterday to, 10 years from now. It's interesting because the growth in load projections for things like artificial intelligence, particularly in Texas with population growth as well, and other industry, everybody's competing for that same infrastructure. They're all the same electrons that everyone's trying to get. And so we have to realize, and our customers realize, that when public utility commissions and grid operators and builders are making decisions about where they're going to invest that money to build out their capabilities, what usually happens is the people who have constituents get the transmission and distribution. And so what that also means is that industries that are operating out away from large population centers typically get deprioritized. And so in some cases, there are I'll say fairly easily identifiable use cases today, even, that if the technology was available today, there would be customers interested in beginning the process of trying to stand up a project to do it. But in most cases, what we see is an expectation of what the future is going to hold. Power prices are going to be higher. T&D is going to continue to be constrained. There's going to continue to be, aspirations and expectations to reduce emissions and environmental footprint. And so a lot of the thinking inside our customers' organizations are strategic and looking more to the intermediate and longer term. But once again, there are folks who would sign up today if we had it. So.
Yeah. All right, thanks, Tim. All right, Mo, question for you about kind of the deployment model that you're looking at. Maybe if you elaborate a little bit more. The question is, will you contract with microreactor vendors on fixed price, cost plus, or some other basis?
So this is something we discussed. I think our preferred contracting with nuclear power producing nuclear power plant would be fixed price, kilowatt hour with the power purchase agreement. But we understand that the cost variables will be for the full life cycle of the nuclear power plant itself. So yes, so the short answer is fixed price will be desired by the government. Yep.
All right, thanks. Spencer, question for you on elaboration on the population siting. The question is, what kind of submittal is planned for population siting?
So the basis, which is in the form of a white paper, is currently being developed. So it's in the form of the white paper. It's currently in draft and is currently being reviewed internally by NEI. I can't remember off the top of my head what the slide schedule was for when that would be submitted to the NRC for their review of that basis, but that will be in the form of a white paper as it currently stands.
Okay, all right. Thanks, Spencer. Jackie, I'm going to go back to you. I think this is a great question that we've asked ourselves internally a lot of times. Can this process be used for reactors larger than microreactors?
So although the focus of this presentation is microreactors, the thought is yes, that staff can apply this process and the learnings from this process to other technologies. And so as we gain experience, and we currently are looking for ways to apply this nth of a kind thought process to other technologies.
Okay, thanks, Jackie. Don, this question's to you, but Jackie, I think you might want to help in a little bit. What is your perspective on physical security presence expected for a microreactor installation? I think that's one of the areas on our integrated plan that we're looking at. I don't know if we necessarily have any thoughts on that yet, per se.
So I think it's going to depend on deployment models and what an applicant is pursuing, and then we can have those discussions in pre-application space. Don, if you wanted to provide anything?
Well, the question is about security.
Yeah, security. So I think it's probably one of the areas one of the topics we'll cover in one of our future workshops.
Right.
And I think.
Yeah, and as Jeremy said, this is captured in our integrated microreactor activities plan.
Okay. Tim, how are you thinking about management of shielding with microreactors?
I am in favor of shielding for microreactors. I was a chemistry and radiological controls officer on my first ship. And so I had to deal a lot with shielding issues and dosimetry and things like that, radiation health. So from our perspective, we believe, obviously, the most important thing is safety. And there's no compromise on safety when it comes to be able to deploy these kinds of units. Our friends, our families, we work in these areas. We work around this equipment. Our folks in our state earn a living in these industries. And so safety is number one. The oil and gas industry has a very strong safety culture as well. I would say not as great as nuclear. Nuclear is still probably the best but it's very strong. And so when we think about things like shielding, obviously there's a process by which the vendor, the designer, is going to have to go through the process of convincing the NRC that they have the appropriate shielding, it's going to function correctly. When we think about deployments, we are talking about microreactors to specific sites that will sit and operate for anywhere from, let's say, 10 to 20 years. And so we don't necessarily, we're not necessarily talking about mobile shielding issues. So I don't know how different it is than what we see today for fixed sites and shielding. But I'd be happy to be corrected by anybody who has some thoughts on that. So mainly a design issue, but also with our EPC partners, making sure construction quality, and then that should remain in place for the life of the facility. Yeah.
All right, thanks, Tim. All right, Mo, it's probably a pretty straightforward response to this next one, but how important is black start capability to the Department of Defense?
So we want our DoD installations to be black start capable, and that's just we must achieve that to provide the additional resiliency for our installations. But also at the nuclear power plant level, we want that black start capability also in case. And I want to also be clear: this microreactor technology that we are exploring, we're going to use them as a base load capacity for our installations. So it's not going to be the backup power. So that black start capability is also important to us.
Okay. All right. Spencer, maybe a little bit elaborate on some of the submittals any has coming in. Other thoughts on what the industry can do to help with this effort?
Yeah, so I think obviously RIDRA, that 350-page proposal paper that we submitted to you all to review, was probably some of the most radically innovative concepts that we have proposed to date. And so I guess one thing would be to not stop innovating. We need to continue to innovate and find more radical concepts to propose, because what I've seen in conversations we've had with the staff, as well as based on your review, that there's nothing in there that would preclude implementation of any of those concepts. And it seems like the staff has a willingness to review those concepts. So I think industry needs, even looking at Chairman Wright's slide from this morning in the opening plenary, there's a number of applications that you're anticipating to come in, and we should start implementing some of these concepts into those applications for the staff's review and approval, because it seems like you're willing and able to review and approve some of these concepts in those applications.
Yeah, thanks, Spencer. I agree with that. I think it's good dialogue we've had so far, and as Jackie just pointed out, we're not thinking this is limited necessarily to microreactors. Kind of some of these concepts can be expanded, and every time we have a dialogue around the concepts we're talking about here, I feel like we come out with even more ideas about how to move forward. So I agree. I think that's worthwhile.
Hey, Jeremy, can I chime in on that?
Absolutely.
I guess there's an old saying is you don't get what you don't ask for, right? And, a lot of the basis for these asks are looking at other industries that are doing things similar to this, managing risk, managing high consequence, and saying, hey, if they can do it over there, we should be able to do it over here, or at least be open to exploring what that looks like. And I think this is a real opportunity for folks in the nuclear industry to begin to think about what are those assumptions that we carry with us, and to challenge those and really to expand our thinking and our desire to reach for new and innovative ways to do things without sacrificing safety, right? That's obviously the key point. But I think this is, to Spencer's point, the crazier the idea, the better in some cases, because you get a chance to hear it out and think through it. So,
thanks, Tim. I actually think that leads into another question, and I'm actually going to use this as our last one because I think it's a great place to end. And I think because we've all used this term in some form or fashion up here, and we've all used it in some form or fashion in prior interactions. So the question is, what do we mean by inherently safe with these designs? So maybe we'll just go down the row. Spencer, how about I start with you this time and kind of work back? And our buddies
Your
with
technical
NEI.
opinion, Spencer.
Don't say I never did anything for you.
Yeah, okay. Safety by design always comes up in my head, and the advanced features you're starting to see, whether it's natural circulation or the different concepts, the TRISO fuels, or any of the fuels, the advancements in those, and any of the new features that advanced reactors and microreactors are developing in their designs, such as passive safety, where there's no operator intervention, things like that.
Thanks. Mo, any thoughts?
So for me, I think about inherent safety, the less the operator have to do on a military installation, less buttons you have to push, more automated system that leads into your safety by design, into concepts that, have the cooling systems without requirement for power, the passive cooling. Those things come to my mind. Yep.
Thanks. Tim?
Just to pile on these two definitions over here, I think when I think about inherent safety, I think about safety features that are genuinely physics-based and rely on passive systems instead of active systems to ensure that the dose consequence to the public in the event of an accident is below acceptable limits. That's one way to think about it, and the other way to think about it is if an operator doesn't have a safety function allocated to them to ensure that we can continue to maintain reasonable assurance of adequate protection, that would be inherent safety in my mind.
On maybe even a twist for you.
Well,
maybe
it's kind of
from an
tearing off
environmental
what
standpoint.
Tim just said. From an environmental point of view, we're assessing, the impacts to the public. So, no significant health effect would be one indicator of that, as far as what I would say. And then the fact that there would also be no significant economic impact that a postulated accident could affect the surrounding area. So it's on that line of no significant impact that could result.
Thanks, Don. Jackie?
My answer, it'll be very similar to what's previously said about inherent or designing for the safety and having the passive systems where you're not relying on significant operator action or any operator action. And as Don also said too, no significant safety impacts related to the environmental.
All right, thanks, everybody. I think that lots of good points. I think everything you all pointed out is definitely aspects that the staff's looking at when we do our reviews, consider all the work that we're doing in this area for all advanced reactor activities, and also leveraging the years and decades of experience that we have in the nuclear industry as a whole, and kind of understanding that how we move forward. Even though some of these designs are using materials in a different way, it doesn't mean that we don't know anything about them or the way they perform. So with that, we're at time. I want to thank you all for participating. Thank you all to our panelists. A round of applause for Also, special thanks to our session coordinators, Jorge Hernandez and Andrew Miller. So thank you both. And again, thank you all for participating. On the screen, you'll see a QR code that you can scan. We are interested in your feedback on the session and activities associated with that. With that, we wish you a pleasant evening, and we look forward to seeing you all tomorrow. Thank you.